systems of equations, and inequalities. We've done this before. System. Anybody? Yet? Yes. No. Maybe in like computers. Math. It is two or more. Equations. Two or more equations. They typically have multiple variables. So we're going to say this is two or more equations for inequalities. Two or more equations for inequalities. What a solution to that is. So you learned about this probably in Math 1. You learned how to do substitution method, elimination method. You would graph them and see something about them. It's where they meet, yes. So we're going to say is the single point where the equations So if you're talking about a solution to a system of equations, so this is not for inequalities, this is just for equations. When you have a system of equations, it's a single point where the two lines cross each other, and they could be lines, but they could also be curves. So it could be, we're going to look at a lot of those throughout the semester. And we write the solution as a point with an x coordinate and a y coordinate, and we write x on y. I always write it that way. Okay, so we're going to go ahead and do number 1. You're focusing on graphing because up until Math 3, you guys do a lot of like doing stuff by hand. And then in Math 3, we get really calculator heavy where we start to do all that stuff and say, okay, so do it by hand, we're going to do it in the calculator, make it a quicker process. Does that make sense? So we're not going to do substitution today. We're not going to do elimination today. We're going to find those intersection points using our calculators instead. Okay. So this first one, we have x plus y equals 2. Does anyone know what that looks like when you graph it? This one is x squared. When it has an x squared, it's a quadratic. What about just an x? Straight line. Yeah, this is a linear. Okay. So when we look at this, I'm going to go ahead and subtract this with x plus y equals 2. I'm going to minus x. So I've got y equals negative x plus 2. And there's 2 reasons I did that. One, if I don't remember how to graph this, now I can plug it into my calculator. But the reason I did it is because now it's in y equals x plus b form, and so now I should remember how to graph it. So in case you forgot, we start with the y-intercept, so we start at 2. And then we think of the number in front of it as like a fraction. So there's no number there, which means it should have been a 1. And if we take the number 1 and we write it as a fraction, it would be 1 over 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. And then I can go ahead and connect those dots. And then make sure you put arrows on each end. So negative x plus 2. We good with that? The next one is x squared minus 1. So I'm going to go ahead and take x squared minus 1. Do we know where the X button is, right here. So x squared minus 1. I did. You have to do it where y is by itself. Now, the nice thing about guys is this is an EOC class, which means we have like the big test at the end. The interesting thing about the test at the end is they use Desmos. Have any of you used Desmos before? The cool thing about Desmos is you don't have to get y by itself, so we would actually be able to type x plus y minus 2, and we don't even have to solve for y. But I'm not going to do a ton of stuff on Desmos yet, because it'll be easier once we have computers. And since we can't get those till Monday, I'm just going to wait for that. All right, so there's our two equations. I'm assuming most of us are great at doing parabolas by hand. Anyone did for that? No, lots of blanks. So go ahead and hit second graph. And since this is the equation we had, we're going to look at y2. Points to graph that one. So I've got the point 0, negative 1, and the point 1, 0, and the point 3, and the point 3, 8. So you can see there's the right side of my parabola right here. I need to go the opposite direction on my calculator. So negative 1, 0, negative 2, 3, negative 3, 8. So second graph, that's how I got to this. And then if you need to scroll up and down to get other points, column. So there's this one, negative 2, 3. You're just starting in the middle of the graph and going left 2, up 3. Did you graph anything in your y equals? That's why. So it will do it from your y equals, so you have to have first. Yeah. My screen looked like that. These first couple, I realized since they looked like this, I realized that right side of the parabola, and I could tell that because when I look at the graph, you can see like here's the right side. So I knew I needed something over here, and that's how I needed to go look for those. So that's when I did, when I went back over here and I scrolled up to get some more negative values. We all have it graphed? Now, when you did stuff like this in Math 1, they probably had intersections that were nice. So it intersected like 1, 3, something like that. In this class, since we're using calculus for answers, they're probably going to have nice intersections. So if you look at this, it's like maybe it intersects at 1, 1, but probably not. It's probably a little bit off of that. And then this one over here is definitely going to be a decimal, and that's because I did that on purpose. Since we're in Math 3, we're going to get a lot of decimal answers. So we're going to go ahead and find these intersections. And to get the intersections of graphs, you hit second trace. There's the second trace takes you to a menu of options. Those options are different things that you can find on your calculator. So second trace. And we're going to go down to number 5. We're going to find the intersection. Right. So press enter. There are 2 intersections. There's one right here and there's one over there. And so what we do with the calculator is you don't have to use a cursor. You don't have to put cursor on top of the intersection, it just has to be close to one of them. So right, it's the one on the right because that's the one it's closest to. Does that make sense? Okay. So I don't have to, I'm just going to press enter, enter, enter. And so this is my intersection. So you should get your x coordinate is 1.3, 2 rounds up to 3. So 1.3 and 3. The y coordinate is 0.697. Did we all get that? Okay, I'm going to write that down. I've got 1.3 over 3.697. And then to one, I'm just going to do the process again. Second trace number 5. And this time, now you can see my cursor over there on the right one. I'm just going to scroll to the left. And I don't have to be on top of it. I just have to be closer to it. So now I'm closer to the left, and I can press enter, enter, enter. So your calculator is hard to find it if it's there. Keep finding the first one over and over. So all you have to do is move towards the second one. You don't have to be on top of it. A lot of students get deliberate and doesn't care about that. You just have to be close to it. Okay. So we got negative 2.303, 4.303. Fun. Okay. This is terrible. You gotta you can crack a smile. You can yawn a little bit if you need to. You can. Okay. All right. X minus 3y equals negative 9. What can I do to get the y all by itself? Maybe. Yes. Okay, so I'll subtract the x over, y equals negative x minus 9. The repeated buzzing that you're hearing is myself on my desk. And I'm pretty sure it means that the girls in my book club are talking about the book we just read. So, sorry, they do that sometimes. They have jobs that they can text at their desks or whatever. I'll fix it in a little. But if you keep hearing it, have you guys been missing it? It keeps going off. It's a group message. Are group messages annoying? Sometimes, man. All right, we got to get rid of the negative 3. Yeah, we're going to divide everything by it. So the y is all by itself. I have a negative 1 in front of x, and I divide that negative 1 by negative 3. Positive. And we're going to write the fraction. So we got 1/3 x, and then we've got negative 9 divided by negative 3. Positive 3. Okay, so how do we graph that one? Yes. Mm-hmm. 1, right 3, up 1, right 3, direction 2. And then what's this going to be? Let's got that squared. Go ahead and start typing these in so you can do the equation first. So you can type your 1 like that, 1 divided by 3. That works fine. If you have a calculator with an updated operating system, then you can hit the green button, alpha y equals, and number 1 is you have to type in a fraction. So 1/3. So if you have yours, that's one of the old ones that can be updated. So I'm sorry, yours is just that you have to do 3. Yeah. But if you have a calculator that looks like one of the color ones, you should be able to do this. And if you can't, it just means you need the new operating system system, and I can fix that for you. So I can update the operating system on your calculator if you were not able to do that. Okay, you just have to let me know sometime and I'll do that for you. So again, the way that I got the 1/3 is I hit alpha y equals. All right, so that's 1/3 x plus 3. And then for the other one, we've got negative x minus 4 squared plus 4. Yeah.
Do you need to solve the second one?
So the first one was written in standard form, the second one was written in vertex form, and your calculator is good with both of those.
I tried to rewrite it.
I mean, you can. Anytime you mess with an equation, you risk making mistakes that could affect your answer. And so if you can plug it in the way it is, then we can. All right, so we'll go ahead and graph those. There's our equation. And then there's our parabola right there. Okay, so let's go ahead and get points for the parabola again. So I'm going to hit second graph. And if you look over here, see how when I use that fraction button, it versus fractions. You guys see that? Okay. I think this one day. I think if you do, hold on, ignore me for a second. If you don't want them to be written as fractions because fractions are harder to graph, then at the end, you can get past that 3 and you can hit the math button. And number 2, you can say take my answer and turn it into decimal, so you can still type it in like a fraction because a lot of students prefer to type things that way to make sure that they look right. But then it will give you your decimal so that they're easier for you to graph. Okay. So now if I do second graph, you can see that all those answers that were fractions are done now. And you can do the same thing the other way too, as you can say turn them all into fractions for me. Okay, so over here, negative 4 with 60, I can't graph that, that's way too big. I can do 1, negative 5, and I can do 2, 0, and then to get some more points, I have to go back over to the x and scroll down a little bit further. So I will try as much as I can with you guys to make sure I'm not going too fast when I teach you guys calculator stuff, and I will try to be repetitive with it and keep showing you the same thing over and over so you don't feel like you have to and kind of pick it up. Okay, so don't worry about wasting time to write down exactly how we got to each thing because I'll be repetitive about that. Okay, so I need some more x values over here. So I've got 5, 3, 0, 7, negative 5. What do you guys notice is kind of interesting about this one? Yeah, they don't touch. What does that mean? There's no solution. There's no solution. No, you're doing it right. And I want you guys to see what happens if you try to find the intersection when there isn't one. We're going to do second trace, just like we did that first time. And we're going to go down to number 5 to intersect. And just like the first time, enter, enter, enter. And your calculator will give an error message if they don't cross. Next. Okay. All right, let's look at the next one. So we've got y equals x squared. What should I do? Say it again. In our calculator. So I've got negative x squared, and then I'll go ahead and hit second graph just so I can get those points. had all week. You're like, thank goodness I came back from Christmas break to do this. That was a sigh of content. Like, this is so wonderful, you know? What a fun class we had. Oh, it's rough. All right, there's our parabola. Ow, this happens all the time. Hold on, I'll get started again. You guys have to draw those parabolas. I'm ready to graph. What's wrong with it? The negative in front of the y, so we need to divide by negative 1. So we have y equals minus 5. So we got the negative 5. And then what do I do for x? So the number of would be 1. If you write it as a fraction, we got 1 over 1. So up 1 over 1, up 1 over 1. So what do I do now? On the intersection, so I've got, what should I type? Trace over 5.
What do you want us to write?
3 places. All right, press enter, enter, enter. So we've got 1.791, negative 3.20, and I'm going to round it to a 9, since 8 had a 7 after it. So I'm going to round it up. All right, how do I find the next one? Make sure I'm closer to the other one. Did you guys notice it took me a while to scroll over there because I was on the parabola? So if you are being lazy and you want it on because that's straighter, you can do a down arrow and it will hop to the other line. And then you can scroll. You're like, wow, that saved me 1/10 of a second. Thank you, Miss Rice. Appreciate it. You're welcome, you guys. Time is money, you know? What fun. Isn't this fun? Are you guys having a grand time? Oh my gosh, what time is class over? It's like next already. Class is over at 10:25. We have at least 40 more minutes to get up. Are you excited? Let's get to this next one, folks. You guys are such a tough crowd today. I'm trying real hard here. All right, what do I do? Yeah, divide by 4, divide by 4. And if you're like, ooh, I do not feel like doing this math, you can even type it in like this. Alpha y equals, right? Because that's how we get that fraction. I'm going to be like, I don't feel like graphing this. So I'm going to well, you can't. Sorry. You have an older calculator. Okay, here's the type it. Are you ready? You're going to type the part in parentheses, and then you're going to hit divide by 4. So you're going to do parentheses 16 plus 5x, end parentheses, and then divide by 4. Perfect. All right. Now we're going to write it. It's a straight line. Expected that. And then, oh my gosh, those are decimals. Terrible. What do I do? You guys want decimals or fractions? Sorry, I said decimals, I meant fractions. Fractions are graph. I'm going to go back to my y equals and fix it by doing math decimals. Later, you guys will be like, oh my gosh, my teacher taught me the best things. I promise. All right, so left 3, up 55, left 2, up 1.5, left 1. Also, whenever you have decimal ones, you can kind of skip the decimals that are on the graph and just do the easier ones. It still makes the same line. What do you guys want to do with the other one to make it so that we can graph it? Say again? Yeah, for this. Do you guys like decimals better? 0.25x plus 0.51. I like fractions better because they're easier to work with by hand. That's fair. Are a lot of you guys planning on doing like going on to pre-cal and calculus? Yeah. So those of you who are going on to calculus, you have to get over your fractions. Yeah. You take class again. Goodness right, it's only been one day. I don't get committed. All right. What else could we do? We got to be able to graph this.
We can multiply everything by 4.
You can do that. What was the benefit of multiplying all of it by 4?
Well, not 4.
You could 4 was right. You're right with the 4 because the 1/4. It would give you all whole numbers. Okay. So there's a math for you. Yes. I answer all these questions for you. I got you. Okay. What else can we do? We want to. Our goal is to the y ones. We can graph it. We can graph it by hand, but we don't have to graph it by hand because we saw that neat little calculator trick over here. So if you don't want to graph it by hand, you don't have to. What should we do? The calculator needs the y to be alone. Yeah, we could minus the 0.5y. We got negative 0.5y equals 1 plus 0.25x. And then what should we do? Yeah, negative 0.5. Now you can deal with all those decimals, fractions, all that if you want. Or you can type it in just like this. So we've got 1 plus 0.25x divided by negative 0.5. Yeah.
The y equals negative 1 over 8x minus negative 0.5. Is that correct? Or did I do it wrong?
So if done it, by hand, I would have left it in the fraction form, like this. And then to get the y alone, I would have multiplied by -2 to get rid of it. Does that make sense? Yes, you'd have to multiply. You could divide by -1/2, but dividing by fractions usually messes with you more. And just multiplying by the negative number, so y equals -2 minus 2 times 1/4 is -2/4, or -1/2. Alright, so we've got that. Our calculator can handle it either way. And since that was the second one I plugged in when I graph it, I'm going to look at y2. So I've got -6, +1, -4, 0, -2, -1, 0, -2. And shocker, it crosses at a decimal. Crazy, huh? Okay, so we're doing second trace number 5, find that intersection. And what do you guys get?
-4.571 and -1.714.
I think you have a typo somewhere. So we rounded the third decimal up on both of those because the 8 was followed by a 5, so you round up. The 5 was followed by a 7, so you round up. There's our intersection. All right. We're going to get to practicing. Are you so excited? How fun. All right, let's look at the first one. So they have a straight line, they have a parabola. I can see one intersection down there. Is that the only solution? Yeah. So if you followed this parabola, it's probably going to go like this, and you followed the line, go like that. So they're definitely going to cross. They're just going to cross outside of the graph. Does that make sense? It doesn't mean that you don't have an answer. It would if these were supposed to have stopped, but they've got arrows, which means they keep going. You have to find those answers too. So let's go ahead and graph these. X squared, 3x plus 5. I'm sorry it's been like weird today. Okay. So let's go ahead and find the easy one first. So second trace, number 5. Enter, enter, enter. Okay. Are that the easy one? Yes, that's right. Marvelous. Okay, this one. Okay. For the other one, we're going to do second trace number 5 again. And I'm going to hop over to the straight line because I don't want to watch it scroll. Okay. So there's my cursor right there. See that? You can tell where the cursor is because it's down here. These are the x and the y coordinate of the cursor that you're on. So I'm just going to move it a little bit more to the right. I'm just going to press enter, enter, enter. Look, it found it. I can't even see it. My calculator still found it. Isn't that tricky? Nobody's excited for me. Rude. So your calculator will find it as long as the x value is one of the x values that's on the screen. So my my x's go from -10 to +10. So as long as that intersection was happening between -10 and +10, my calculator would find it just fine. That's because the domain, have you guys heard that word before? The domain of the function was on the screen. Okay, so if I were to switch my domain of my function to be from -3 to 3, let me go ahead and graph this again. I just chose it. I chose it because 4 is outside of the domain. Oh, the window. Yeah. So if I were to change my screen from -3 to 3, so it's off the screen again, right? And then I were to do the exact same process. So it said find the intersection for me. I could go ahead. I'm going to move it over here. My calculator will only find this one. It will not be able to find the other one because my screen only goes to 3 and that intersection was at 4. So in some ways you're a little bit limited in that if the domain, if your screen is not wide enough, it might not find answers that are actually there because you need to change your screen. Does that make sense? So as long as I could tell I didn't need to make it bigger for my default screen because I could see right here, I could see that it was about 4 in there. But if that's you, then I'm not sure that it changed. I can come over and help them in a minute. All right, so go ahead and keep working on those 1 through 3 is what we're working on right now. So go ahead and look at the other two. Do you guys remember what inequalities are? Inequalities. It's your notes, but on the back side. They do not have an equal sign. What do they have instead? Greater than or less than, or they could have less than or equal to, or greater than or equal to. Back of your notes. All right, so if the inequality has a less than sign or a greater than sign, then you draw it with a dotted line. Does that ring a bell? And then if it has an equal to with it, you draw it with a solid line. So what that tells you is that when you have points that are on a solid line, they would make the equation or the inequality, they would make them true. If you dotted line, then the points that are on that dotted line would make the inequality false. They would not work. So true, false. Okay. There's another piece to it. So you're going to draw the line itself, and then what else do you have to do if you're done drawing? You have to shade. Okay. So you shade. You're picking x and y coordinates of points, and those x and y coordinates have to be true. So you could say shade where it's true, or you could say pick a point and plug it in and shade where it works. I don't know how you want to write this on notes, so you can write it whichever way makes sense to you, but I'm going to go ahead and say shade where it's true. Most teachers teach you to plug a point 0, 0 because we like to be lazy and 0, 0 is the easiest to plug in. But sometimes the line itself goes through 0, 0 and then you have to pick a different point. So really you can pick any point on the graph. It just has to be like on one side of the line or the other. And then we're going to shade where it's true. So the solution to a system of inequalities, it can still be where the lines intersect as long as they're both solid lines. But you're going to look at where the shading intersects as well. Okay, so we're going to say where solid lines and shaded regions cross. A lot of times when two shaded regions cross, I call that a double shade because it's shaded twice. Doubly shaded. Doubly shaded. Doubly. So when you have a solution here, you're not just going to have a single point, you're going to have a bunch of points, like a whole area, basically. Okay. So let's go ahead and start with this one. We've got negative 1/3 x minus 2. Where should we start? Minus 2. And where do I go? Down 1, right 3. Down 1, right 3. That says greater than or equal to. So is that a dotted line or a solid line? Solid. Okay. And then you pick a point, any point, it doesn't matter, but I'm going to pick 0, 0 because it's easy. So 0, 0 is above the line. 0 for x, 0 for y. So if I take that equation, I put 0 for y and 0 for x, and I have to see if it's true or not. So I've got 0 is greater than or equal to 0 minus 2, which is negative 2. Is it true that 0 is bigger than a negative number? Yes, that is true. And we shade where it's true. So if this side is true, that means this side is false. So each side is one or the other. Does that make sense? Okay. So I'm going to go ahead and shade right here. Okay. And then we've got that parabola. So I've got negative x squared minus 2x plus 3. And I'm going to go ahead and look at that page so I hit second graph. So I've got negative 4, negative 5, negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, 2, negative 5. Does the parabola get a solid line or a dotted line? Dotted. Now, when I say for a parabola, I've got inside the parabola and outside the parabola. Does that make sense? So instead of having like top versus bottom, I've still got two sides. It's just inside versus outside. The point 0, 0 is inside the parabola. So I'm either going to shade inside or outside. So I'll go ahead and plug this in. I got 0 is less than negative 0 squared minus 2 times 0 plus 3. So 0 is less than 0 minus 0 plus 3. 0 is less than 3. So is that true or false? True. 0 is less than 3. So this point is on the inside of the parabola, and that is true. So where do I shade? I shade all of inside the parabola, like this. And then for my solution, I usually go back and make it extra dark right there. So where did I shade twice? It was just this part right here. This part got shaded twice. So this is my solution right here. So if I was to describe my solution in words, I would say that my solution is inside the parabola, but above the line. Inside the parabola, but above the line. Does that make sense? So inside the parabola, but above the line. The points on the parabola are not solutions. The points on the line are solutions, as long as they're inside the parabola. So each of these little points are solutions. These points over here are not. So solutions, not solutions. Is the intersection a solution for the parabola and the line cross? One of them solid, one of them solid. No. So no. So our solution is where solid lines cross, and this is a dotted line and a solid line. So our solution would be the portion of the parabola that's above the line. So inside the parabola, above the line, we include the point, but we don't include these points. Does that make sense? Okay. Let's try the next one. So I've got x squared minus 4x. Is the parabola solid or dotted? Solid. Can I use the point 0, 0 to figure out where to shade? Yeah, on the line. We have to find something that's inside or outside. So what's a point that you could choose? It can be inside the parabola, it can be outside, it doesn't matter. But what's a point that you could use that's not on the line? You can use anything that you like. Mm-hmm. 1, 0. So 1, 0, 0 is going to be inside the parabola. So we'll put 0 in for y, and then 1 in for x, and then we're just going to see if it's true or not. So 0 is less than 1 minus 4. 1 minus 4 is negative 3. Is 0 less than a negative number? No. So this is where the point is. This is false. So inside the parabola is false. That means that outside the parabola is true. So where do we shade? Outside the parabola. Okay. What do I have to do so that I can graph the next one? Mm-hmm. So what should I do to get the y by itself? We can subtract the y over, we could add the x over. What would we rather do? Add the x? So if we were to put a y-intercept on this one, it would be a +0 on the end. And then in the front, that would be a 1. So we start at 0 and go up 1, right 1, up 1, right 1. Dotted because it's a less than sign. And we can't use the 0.00. We could use 1, 0 again. So if I've got -1 plus 0 is less than 0. -1 is less than 0. That's true. So underneath the line is true. Above the line is false. So that means we're going to shade below the line. So the double shade is everything that's below the line and outside the parabola. Below the line and outside the parabola. And then points that are on the parabola can be included in the solution, but points that are on the line cannot be because it's dotted. So below the line but outside the parabola, you can't have the intersections because you got a dotted line in there. Okay, so go ahead and work on 4 through 6. I think I want you guys to do 4 through 6 and then 10 and 11. 4 through 6, 10, and 11. So you can skip 7, 8, and 9. Sound reasonable? Okay. 4 through 6, 10, 11,